In an urban landscape like Baltimore, critical networks often get disconnected through time. Transcending Resilience replaces the existing network that comprises the current infrastructure of Baltimore with reliable connectivity, re-envisioning the critical transportation routes in the year 2100 on the coast of the city in the scope of climate change. The approach of this plan is not defined to a precise city, but can be used as a guideline for any coastal city. The current conditions of Baltimore's Middle Branch are not satisfactory to both human users and wildlife. Inaccessibility to the waterfront and inefficient transportation routes has led to a disconnect between spaces. Pollution of the water and air has led to habitat destruction as well as an increase in negative health effects, particularly asthma. Baltimore's early public transportation system was largely dominated by streetcars until the rise of the bus system. Bus ridership in the United States has slowly been declining as track-based metros, subways, and commuter rail become more popular. However, like most U.S. cities, the transportation network is dominated by cars. Solving transportation issues requires an in-depth knowledge of the present transportation types and access. Therefore, we analyze public transportation routes, major highway routes, bus stop accessibility, vacant housing, and ways that these modes of transportation had an impact on public health. Our study area is in the middle branch of the Patapsco River and its surrounding neighborhoods. In the adjacent area, there are limited public transportation routes. This area is sparse compared to areas like Inner Harbor, which have a high volume of public transit. Not only is public transit beneficial to the environment, but it aids public health as well. Over 10% of the people in the study have asthma. Asthma is a severe health condition that can be worsened by vehicle emissions. Not only do people in this area suffer from asthma, but the entirety of the study area is deemed to be medically underserved. Medically underserved indicates that there is limited access to medical doctors or treatment. Limited access requires people to find public transit, which is also served in this area, or drive their vehicle, emitting harmful pollutants. Using different projections and calculations of sea level rise, we discovered that 250 acres of waterfront in the Middle Branch will be underwater by 2100 due to climate change. Many of the surrounding neighborhoods are already experiencing high amounts of vacancies, and this is only expected to become worse as sea levels rise and residents are forced to relocate. It seems possible in the future to reduce environmental impacts of climate change, as well as public health impacts, through envisioning the transportation routes through the Middle Branch as a more interconnected network and extending a critical part of that network to cities across the eastern seaboard. Several climate change issues, such as sea level rise, transportation methods, and public health, are addressed in the planning of the Middle Branch. The Hyperloop, a fast-traveling underground vehicle and train route, reimagines how we look at coastal transportation in the future. This tunnel also serves as an underground wall, restricting a groundwater flow and holding back potential sea level rise. Imagine an underground seawall, keeping the city safe from the relentless flooding we may see in 2100. The system assumes the widespread use of autonomous electric vehicles in the future, allowing for fast travel. Vehicles will enter the Hyperloop through a series of ramps that connect street-level transportation to the underground, high-speed route to other cities. The vacancies in the area, as well as the 2100 sea levels, predict the need to imagine our infrastructure differently on the water's edge. High-rise buildings allow for mixed-use, denser population, and is proven to be the most sustainable living option of the future. Buildings like this will not be uncommon in the year 2100. Predicting this shift in living styles, as well as maintaining a connection to critical transportation, will be crucial in the future of urban fabric. Hexagonal-shaped smart islands drift on the surface of the Middle Branch, each with a particular typology geared towards climate change. The hexagons are equipped with either algal solar panels, trash and particulate vacuums, vegetation, or can carry humans with a more extensive ferry network. These smart machines are programmed to learn the qualities of the Middle Branch and beyond, and can drift throughout the Chesapeake Bay. They operate by docking to charging stations throughout the Middle Branch, each supplied with energy from the kinetic absorption tiles throughout the path network. Around the Middle Branch, pressure-sensitive paths generate energy for the city and are the primary source of connection for the pedestrian and cyclists to reach the adjacent neighborhoods. Currently, there's only one way to get across the Middle Branch of the Patapsco, an old vehicular prioritized bridge. The design of the path network creates 8 connection points, which allow pedestrians to cut their travel time in half if they need to get to the other side. These path networks generate enough energy from the steps of those who walk on it to charge smart islands that move throughout the middle branch electronically. In the scope of climate change and increasing temperatures, engineered species planted adjacent to the paths in the marshland are equipped to withstand higher temperatures within the middle branch waters and on the surrounding archipelagos. These species mock the historical qualities of plants like horn pondweed, water thyme, and redhead grass, but are genetically engineered to be more resilient to climate change. The connection of smart islands to the path network is important in creating both a site-specific network and an inner-city network of travel. The docking allows the transfer of generated electricity from the paths to the smart islands, allows for the products filtered from the water to be removed, and allows people to enter and exit the smart islands when being used as a ferry throughout the bay. The implementation of this plan is a multi-phased approach, starting with the introduction and expansion of marshland in 2020. In 2030, the installation of the path network with kinetic absorption tiles begins. The infrastructure to install the Hyperloop begins in 2050, along with higher density mixed-use construction along the waterfront. By 2100, the design should be fully implemented with marsh vegetation having ample time to reach maturity. Our design was initially crafted in a way that could be a prototype for other coastal and waterfront cities. Using the Northeast Corridor as the initial prototype, we've identified 4 other regions within the United States that could implement similar design interventions. The West Coast, Midwest, Texas, and Florida all have clusterings of cities that would be able to create a Hyperloop connection, as well as implement site-scaled projects with kinetic absorption paths and smart islands.